James is the director of CSIRO Futures, the strategic advisory arm of Australia's National Science Agency. He leads a team that builds on CSIRO's deep research expertise to help clients create sustainable growth and competitive advantage by harnessing technology and innovation. He has overseen the development of CSIRO's Industry Roadmap series, including the National Hydrogen Roadmap, the Space Industry Roadmap, and the Low Emissions Technology Roadmap. James?
Thanks very much, Yuli, and thanks everyone for allowing me to join you here this afternoon. I think that was an excellent overview that Yuli just gave us all on the imperative for sustainability in aviation and the role that technology is going to play in helping us realize that. My team at CSIRO have had the privilege of working with Air Force over the last 6 months to help analyze some of the options available, some of the technologies available, and to look at the timeframes that we could achieve that within in terms of setting up both a pilot program initially and then longer term, how we build a more sustainable Air Force into the future. Before I go through some of the findings and talk about that in more detail, for the benefit of some of our overseas audience and some of our overseas guests here today, you may be wondering, what is CSIRO, if you haven't heard of us before. We are Australia's National Science Agency. We have about 5,000 researchers who work here in Australia across a wide range of industries, and we operate in more than 80 countries around the world on a number of different research challenges. The I in CSIRO stands for industry, and our work is very much at the applied end of industry. And that includes a long history of working in aerospace and working with defense, both here in Australia and overseas. We've managed NASA's assets here in Australia for more than 60 years, and I'm proud to say that we have a very long-standing partnership over 30 years now with Boeing, and jointly we've invested more than $120 million across a range of projects over that 30 years. With that out of the way, that's who we are. What I'd like to talk about today are the details of the project that we've been working on with Air Force. And in that, we've looked at the role that sustainable aviation fuels, or maybe more generally, alternative aviation fuels, could play in achieving 3 objectives. So Yuli talked at length about the importance of sustainability and emissions reduction as part of our effort to reduce climate change impact. In addition, we're also looking at the opportunity to build more deployable modular solutions for generating aviation fuel. And that's very important here in Australia, given the dependence Australia has on imported fuels and on a diminished refining capability within Australia. The third objective, which is closely related to that as well, is increasing our fuel security here in Australia. And we think that the technologies that are available today and the emerging technologies that we will see into the future can help Air Force and aviation in general achieve all 3 of those objectives. I want to talk very briefly about a couple of those issues. And I think, when we look at sustainability and we look at the options that are available to aviation, it's unlike so much of industry, unlike our electricity sector, unlike transport. The challenge with aviation is that we have no easy options to decarbonize aviation. The constraints that you face on an airframe with respect to weight mean that electric battery-operated aircraft, at least at this point, are only feasible for the very shortest of journeys and don't meet the mission at this point for defense aviation. Looking out further, we see an opportunity for hydrogen in aviation as well, but that's very much a longer-term play. And again, the challenge there is the amount of space that you would need on an airframe to store that hydrogen means that conventional aircraft aren't suitable. And we'd be looking at some significant changes to the airframe itself to achieve that in the longer run. And when I say longer run, we're looking at probably somewhere in the 2040s for that to really take, to have uptake. So what we've focused on in the short term, in the near term, are what, as Yuli referred to them, drop-in sustainable aviation fuels or alternative aviation fuels that work with existing jet engines, that work with existing infrastructure, and that can be blended with conventional kerosene, Jet A, and used with that existing equipment. There are a number of ways to achieve this, a number of ways to produce those alternative aviation fuels, and as part of our project, we looked at 19 different configurations for how to produce those fuels based on the 7 standard globally accepted ATSM certified pathways for producing alternative aviation fuel. Importantly, as part of those considerations, we looked at 12 different criteria for evaluating those different pathways. And importantly, we looked at the availability of indigenous feedstock here in Australia. And Yuli mentioned a couple of the potential feedstocks. Patrick talked about hydrogen earlier as well. We looked at technology readiness. How quickly could it be deployed? Is the technology mature? We looked at the opportunity to intensify that process, to scale it down and make it deployable and modular so that it could be positioned either on base or even potentially in theater in the future. And we looked at the amount of sovereign capability that we have here in Australia to deploy and maintain that equipment as well. And we set, we looked at what's possible in the long term, but what could we, importantly, what could we get up and running in a pilot program in the next 2 years? And the good news, cutting to the chase, is that there are a number of options available, and we think it's entirely possible that we could achieve that here in Australia within that time frame with technology that's available today. So I'll touch on, I want to talk about 3 different time frames and 4 pathways very quickly that we could use to achieve that. The first is what's called HEFA, H-E-F-A, and that's hydroprocessed esters and fatty acids. Yuli mentioned this one as well. Basically, it's taking, you can use a wide range of seed oils, vegetable oils, or even tallow, and you can convert that through a process into alternative aviation fuel. It's a technologically mature pathway. The vast majority of sustainable aviation fuel today is made using that pathway, and most of the commercially available sustainable aviation fuel uses that pathway. There's about 200,000 tons of production today, but that's expected to increase to around about 5 million tons by 2025. Here in Australia, importantly, we have, because of our significant cropping, this is it is very well aligned to our situation here. In fact, our canola oil production alone here in Australia would be sufficient to meet the entirety of our RAAF's needs for aviation fuel. And when you look at modularizing that or componentizing that, with a single tanker truck of canola oil, you could produce somewhere around about 100 barrels a day on site, on base, in a small-scale production facility. The challenge is the economics, and I'll touch on the economics at the end of my presentation because it's something that's in common across all of these pathways. The other challenge is the food versus fuel trade-off. And you can imagine in a world where food demand increases with population and we have potential food shortages, perhaps as a result of climate change, there's a risk in associating your fuel supply with something that could be used otherwise for food. And so there are opportunities there to use non-food crops as well. The second pathway to producing fuels, and this is also a short-term, immediate-term pathway, is using the Fischer-Tropsch process, using natural gas as a feedstock. And of course, we have an abundance of natural gas here in Australia through our LNG processing. And this is also a mature technology, although not as widely deployed in the creation of alternative aviation fuels as HEFA, the first pathway. There are also opportunities with this technology to modularize it, to make it deployable, but that's in early stages and would be the focus of additional research to get it there. Today, if we looked at natural gas as the feedstock for that process, obviously it's not going to be as sustainable as other options. You're using a fossil fuel as your input. But what that would do is it would give you a pathway to future options that could use CO2 and hydrogen as feedstocks that would be lower emissions and potentially even zero emissions. When we look at more the medium term, say in the next 2 to 5 years, that in fact is one of those opportunities, is you can use that same Fischer-Tropsch process but use CO2 as an input. And you could use CO2 from, say, a direct feed like a flue gas from industry or a waste output from industry, combine that with hydrogen and have a sustainable aviation fuel there as well. It would require a large quantity of hydrogen, and Patrick touched on some of the work that's being done today to scale up hydrogen here in Australia. And we envision that very much would be within the range of what would be available to us. The other interesting thing about that pathway is in the longer term, when we look out 5+ years, 10 years out, there's the opportunity to transition that pathway into liquids to fuels or electrofuels, where you're taking CO2 that could be captured out of the atmosphere or from seawater, for instance, combining it with hydrogen that's produced via renewable energy, and you have a zero emissions, theoretically zero emissions jet fuel that could be produced anywhere in the world that you have access to air or seawater and power, sunlight that can be turned into power. We've seen the United States Air Force has done a very small pilot program looking at this, and I think we're still a number of years off from that being a reality, but that is, I think, the long-term goal for sustainable aviation fuel that would be truly zero emissions, truly deployable, and would give a number of different options for deploying it in theater as well. I said that very quickly the fourth pathway, which is another medium-term one, is what's called alcohol to jet, where you can turn a variety of different alcohols into jet fuel. That could be ethanol, methanol, and so forth. It's yet to be demonstrated at scale, and there's some concern about the costs involved, but that's another pathway that could be pursued. Now, the elephant in the room for all four of these pathways is the economics today. They just don't stack up compared to conventional jet fuel. We're looking at costs somewhere in the range of 2 to 4 times the cost of traditional jet fuel. But we think that will come down over time as we're able to build scale, and technology improvements will help reduce those costs as well. And there's I think, an enormous opportunity when we look at scale, and particularly here in Australia, where, by the way, we are not producing any meaningful volume of sustainable aviation fuel today. There's an enormous opportunity for commercial aviation and defense aviation to work together and bring in Australian research from CSIRO, the universities, and others to help reduce those costs over time. So in conclusion, as I said, we looked at a number of different pathways. We analyzed them across a number of criteria. We have identified 4 pathways, 2 of which we think are viable for immediate term use. And in fact, we're continuing to work with Air Force, looking at the commercially available technologies that could be brought in to bring a solution to bear within the next 2 years. And we're keeping our options open with respect to those 2 pathways. And then a further 2 pathways that we've recommended continue to be pursued, and there will be further research that needs to be done in the medium term, but that will provide that transition pathway to a truly net zero, fully deployable alternative aviation fuel in the future. Thanks very much, and if there are questions, I'm happy to take any questions from the audience or online.
Thanks, James. That was excellent. We've been talking about modular, so this is my question, a bit of a Dorothy Dixer here. Can you give an indication of the size of the kit we're talking about? Because that was one of the design criteria.
Yeah, so when we talk about modular, we're talking about on the order of something that could fit in a shipping container, or multiple shipping containers that could be deployed and hooked up together. There's a couple different scenarios that we looked at there. Probably the easiest would be something that could be deployed at a base, for instance, more or less as a permanent installation, but that could be brought in on the back of trucks or on rail and set up here in Australia. Longer term, we'd look at the potential that that's something that could even be deployed in theater. And as part of that, we did an analysis around the different inputs and waste streams that you would need to manage as part of that. And in the first instance, as kind of a starting point to put some general numbers around it, we're looking at one of those instances being able to produce somewhere in the order of about 100 barrels of jet fuel a day in early on.
Awesome, thank you. Look, we've got time for one more question. In regards to alternative fuel options, is there a fuel being designed to be used across multiple platforms and engine types, including land and air-based? Having a multi-purpose fuel source assists in reducing logistics of supplying and stocking a large range of different fuels.
Yeah, great question. And certainly the intent behind alternative aviation fuels is that they're drop-in fuels for use in aviation. So they work with existing jet engines. They work with existing ground infrastructure. I think the other benefit that you get to many of these production pathways I talked about is that you get other output fuels that come out of it, like diesel, for instance. So you would have a source of diesel sitting right beside your alternative aviation fuel coming out of the same kit that you could set up and deploy.
Thanks, James. I'm just taking director's privilege to add one more question.
Absolutely.
Very compelling presentation. Can you just describe what a meaningful partnership looks like with defence and industry to get what you've just described in place as quickly as possible? What does that look like?
So it's a great question, and I think one could envision a couple of different ways that could play out. But certainly in the consultations that we've done with technology partners, with industry, I could see a route where you could bring together, say, a commercial refinery, a commercial aviation partner, several commercial technology providers where there's available off-the-shelf technology that can be used, and you could do, say, a small-scale pilot initially, set that up in fairly short order, be able to demonstrate the capability, produce a meaningful amount of fuel. And then at the same time, you could pursue another pathway that would look at how do you scale that up into larger volumes. And that might not be deployable initially. It might be dependent on, say, an existing refinery. But that you'd eventually, over time, you'd merge those 2 pathways together. And one of the things that we're very open to as the National Science Agency, we see it as part of our role here in Australia, would be to play a technology advisory role through that process to help guide Air Force and commercial partners in coming together to make that happen.
Thank you. Look, thank you very much, James. If you could put your hands together.
Thanks very much.